Hello students, this is an introduction video to the special right triangles lesson. This is going to be a very quick review of some basic trigonometry that hopefully you already have learned in class. If you have not learned, perhaps you need to seek out those resources first, as the content in this specific video is going to go rather quick. So if this is your first exposure to it, might be a little too quick for you, and you should look elsewhere. But quick review of that content, because the special triangles lesson is strongly tied to trigonometry. So we do have to quickly touch on that first, just so you can see where all this is coming from. All right, trigonometry and special right triangles is kind of the study of right triangles specifically. So anything that you see in today's lesson, whether it's this video or future videos, just remember that that only applies to right triangles and no other type. So a right triangle, as hopefully you remember, is any triangle with one of the angles being 90 degrees, and we can represent that angle with this little square here. And mathematicians discovered that specifically for right triangles, there is a very interesting relationship between the angles of the other two parts of the triangle, as well as the lengths of the sides. And they documented the relationships and the ratios between the sides relative to each angle, and they came up with values for them that are predictable and repeatable, as well as a couple of equations, or three equations, that can help you relate the angles and the sides to each other. So let's quickly talk about those trigonometry functions. There are three of them at the moment. You'll learn about more later. But for now, we're going to focus on sine of theta is the opposite over the hypotenuse. And I'll talk about what all of this means quickly. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. Okay, first, let's quickly decipher what each of these pieces mean. Theta, this is just a new variable that has been given to angles. So anytime you see a theta, it's kind of like an x or a y or an a or a b, but it's in the context of an angle. So in this case, yes, we do have this 90-degree angle here, but because it's always 90, there's no need to give it a variable. What we talk about when we say theta is we might be talking about this angle up here or this angle up here, because those are the ones that do change. All right. Next, sine, cosine, and tangent. They are basically just names for relationships between sides. You don't need to know much more about them beyond that, but just know that sine is the relationship between these two, cosine is the relationship between these two, tan is the relationship between those two. Okay, that's all you need to know there. Now, there are three unique names here. We have opposite, hypotenuse, and adjacent. Let's talk about what all of those mean. First, hypotenuse. Hopefully you remember that hypotenuse in a right triangle always refers to the length that is opposites of the 90-degree side. And coincidentally, it also happens to be the longest side. So in this case, this is going to be our hypotenuse. Okay, again, it's opposite the 90. Now, the opposite side and the adjacent side can change, and they change depending on the location of theta, or the location of the angle in question. So let's take an example. Let's say I care about this angle, so I'm going to call that theta. All right. The opposite side to this angle is going to be the side that this angle kind of opens its mouth to. So that's going to be here. So I can call this the opposite side. And now, as you can guess, the only remaining side is this side. This must be the adjacent side. Okay, and we pop that there. If you were trying to figure out where adjacent was before you figured out where opposite is, um, just remember that the word adjacent means to be next to. Um, so this is the side that's next to the angle. On the other hand, we do have hypotenuse, which is next to the angle, but remember that hypotenuse has to be opposite the 90. So the only option for adjacent is that. Okay? So basically what this is saying is taking the sine of theta, and remember that your calculator can do all of these, right? You have sine, cosine, and tangent. Um, if you take the sine of this angle and you hit enter, that's going to be the ratio between the length of the opposite side and the length of the hypotenuse. If you take the cosine of that angle, that's the relationship or the ratio between the adjacent and the hypotenuse. And if you take the tan of theta, that's the ratio between the opposite side and the adjacent side. Okay? And these have very predictable and very well-known relationships and ratios, and they're all preloaded into your calculator. So the cool thing is, if you know any two of these for any given equation, you can find the third. If you know theta and hypotenuse, you can calculate opposite. If you know opposite and hypotenuse, you can calculate theta, so on and so forth. Okay, so that's it's basically trigonometry. Let's use this in context to give you guys an idea of how this works. So let's say I've been given this right triangle, okay, and I'm told that this angle here is 59 degrees, and I'm also told that this side here is 80. And I'm asked to find this length here, which has been called x. All right, here are the steps I need to follow. First, locate the angle in question. That's this angle right here. Next, identify all the sides, in other words, label all the sides based on where this angle is. Okay, so let's do that. First, hypotenuse is non-negotiable. That has to be opposite the 90. That is this side right here. Okay. Next, these are interchangeable and they depend on the location of my angle. So let's take a look at my angle. I know that the side that the angle opens up to, or the side that the mouth opens up to, is the opposite. That must be this side here. So this is the opposite side to that angle. And finally, the only remaining one is adjacent, which goes here. All right. So the next thing I need to do is identify the sides in question. Two out of the three sides are going to be used in any one of these equations. So let's take a look. It looks like they've given me the length of this side, which is 80, and that's the opposite side. So it looks like I care about opposite in this case. The next side in question is this side. I don't have that value, but I'm being asked to find it. So I care about that side. I care about the hypotenuse. I scan through my trig functions and I locate a trig function that relates hypotenuse and opposite. I can see that that's this one here. I need to use sine of theta. So what I'm going to do is rewrite this equation and fill in all the information I have and find the information I don't. Okay, so it says here sine of theta. So I write sine, and I know theta is the angle, and in this case the angle is 59 degrees, is equal to the opposite length, which in this case is 80, divided by the hypotenuse length. In this case, I don't have the length of this side, but I do have its variable representation, which is x. All right. I have enough information here now to solve for x. So let's do that. I grab my calculator and I pop in a sine of 59 to see what that gets me. Here's my sine button. Click that. Type in 59. Hit enter. And I get that long decimal. It's good to keep as many as you can because they can change the side length drastically. So I like to recommend at least 3 decimal points, or at least 3 numbers after the decimal point. So we can call that a 0.857. Notice the fourth value, which is a 1, rounds down. So this stays a 7 and doesn't go up to an 8. That equals 80 over x. Okay. Now I need to use algebra to isolate x. Perhaps I can multiply both sides by x first. right? If I multiply this by x, it cancels this x. And on this side, we get 0.857x. And all we have on the right side is an 80. And then final step is, I see that this is multiplying x, so I need to divide both sides by that value. Okay, which cancels it here, leaving just x. And on this side, I get 80 divided by this value, which I can put into my calculator to see what works. I get 80 divided by 0.857, and I get 93.349. Okay, and that is it. Okay, that tells us that the length of side x is 93.349. It's good practice to see if that number makes sense based on the context of the triangle. So if you look down here, I do see that this side is a length of 80. And I know that the hypotenuse is always going to be the longest side, so it makes sense for it to be a little longer than 80. So 93.349 makes sense in the context of this. If I got a value like 20 or 10, perhaps I did something wrong and I should check my work. Usually that thing that you did wrong is usually mislabeling one of the sides or using the wrong trig function is a common error there. Okay, so basically that's how you do it. Again, depending on the sides that are in question, you're going to choose the trig function that makes sense to you. Pop in the values that you have, solve for the values that you don't. You will need a calculator or at least a trig table to do that, so make sure you have it handy when you do. Okay, if you can understand this, you can understand where special triangles come from, which is the remaining lesson.